This video will cover beginner questions relating to the topic of maximum, minimum, and critical numbers. Question 1. F is continuous across the interval a and d. Absolute maximum or global maximum at x equals d because it's the highest point. Absolute minimum or global minimum at x equals d because it's the lowest point. But we can also call this point a relative minimum or local minimum because it's the lowest point in this area. Then relative maximum or local maximum at x equals b because f has a highest point around here. Neither a maximum nor a minimum at x equals a. F is continuous on an open interval a and d. Neither a maximum nor a minimum at x equals a. Relative maximum or local maximum at x equals b because it's the highest point nearby x equals b. Absolute minimum or global minimum at x equals d because it's the lowest point, but we can also call this point a relative minimum or local minimum because it's the lowest point in this area. In this graph, the absolute minimum and the relative minimum are the same value. This time, there is no absolute maximum or global maximum at x equals d because f is an open interval a and d. In graph C, f is not continuous across the interval a and d. We already know relative maximum at x equals b, absolute maximum at x equals d. There is no absolute minimum or global minimum at x equals d because f has a hole at x equals d. But there is a relative maximum at x equals c because f has the maximum value around x equals c. Question 2. Absolute maximum at x equals a because it's the highest point. F prime of a does not exist. Do you remember the definition of the derivative? F prime of a equals limit as h approaches 0, f of a plus h minus f of a over h. This means limit as h approaches 0 from the right, f of a plus h minus f of a over h is the same as limit as h approaches 0 from the left, f of a plus h minus f of a over h. In this graph, when x equals a, the right-hand limit is defined, but there's no left-hand limit, so f prime a does not exist. Relative minimum or local minimum at x equals c because its lowest point is around x equals c. F prime of c does not exist because we can't find the slope of the tangent line at x equals c. The graph has a cusp at x equals c. Relative maximum or local maximum at x equals d. The slope of the tangent line at x equals d equals 0, so f prime of d equals 0. Relative minimum or local minimum at x equals e because its lowest point is nearby x equals e. The slope of the tangent line at x equals e is 0, so f prime of e equals 0. Relative maximum or local maximum at x equals f. The graph has a cusp at x equals f, so f prime of f does not exist. Neither a maximum nor a minimum at x equals b. To make it easier to find, you can think of relative maximum as the top of a mountain and relative minimum as the bottom of a belly. The shape of the mountain or belly may be a round shape or a pointed shape. To summarize, question 3. The first point is neither a maximum nor a minimum at x equals 0. Relative maximum at x equals 1 because the highest point is around x equals 1 and it looks like a mountain. Also, a relative maximum at x equals 2. The shape of the actual graph is a valley, but the point is above the original graph because it is a removable discontinuity when x equals 2. So you can think of the point as the highest point near the valley. Neither a maximum nor a minimum at x equals 3 because this point is the highest in this area, but since it is an open interval, an exact value cannot be found. Absolute maximum at x equals 4 because it's the highest point. If it is strange because it is not a mountain, think of it as a cliff. Absolute minimum at x equals 5 because it is the lowest point. Question 4. The first point is the lowest, but it's an open interval. There is no absolute minimum value. F never actual has a minimum at x equals 0. Relative maximum at x equals 1. The value is f of 1 equals 4. Because it's the highest point around x equals 1, the shape of the graph is a mountain-shaped cliff on one side. Relative minimum at x equals 2, the value is f of 2 equals 2. Because it's the lowest point around x equals 2, it looks like a valley. Relative minimum at x equals 3, the value is f of 3 equals 4. Since the shape of the graph is a mountain, it is easy to think of it as a relative maximum. But the peak is a removable discontinuity, so you have to think of the point below it. Since it is lower than that nearby, you have to think of it as the relative minimum. Neither a maximum nor a minimum at x equals 4. The shape of the graph at this point looks like a valley, but there is a lower part around it, and the lowest point is a hole, so you can't find the exact value. No absolute maximum is here. This is the highest point, but it is an open interval. F never actually has a maximum value. This is the last one. In graph A, f prime of A is 0 because the slope of the tangent line at x equals A is 0. Relative maximum at x equals A because it is the highest point around x equals A, and the shape of the graph looks like a mountain. F prime of B does not exist because we can't find the slope of the tangent line at x equals B, and the graph has a cusp at x equals B. Relative minimum at x equals B, its lowest point is around x equals B, and it looks like a valley. F prime C is positive because the slope of the tangent line at x equals C is positive, but neither maximum nor a minimum at x equals C. In graph B, the slope of the tangent line at x equals A is negative, so f prime of A is negative. The slope of tangent line at x equals B is 0, then f prime of B is 0. The slope of the tangent line at x equals C is 0, then f prime of c is 0. Neither maximum nor minimum at x equals a. Relative minimum at x equals b, it looks like a valley. Relative maximum at x equals c, it looks like a mountain. F prime of a does not exist because a jump discontinuity occurs at x equals a. Limit as x approaches a from the left side, f of x is not the same as limit as x approaches a from the right side of f of x. The slope of the tangent line at x equals b is 0, so f prime of b equals 0. The slope of the tangent line at x equals c is positive, then f prime of c is positive. Relative maximum at x equals a, because its highest point is around x equals a. The shape of the graph is mountain-shaped cliff on one side. Relative minimum at x equals b, because its lowest point is nearby x equals b. The shape of the graph looks like a valley. Neither maximum nor a minimum at x equals c is not a mountain or valley shape. I hope this video has been helpful. If you have any questions, leave them in a comment. Thank you for watching. Please like and subscribe for more.